Okay, class, I have a quick question for you on our second day of class. Did anyone have any questions from the last class? Did anyone have any questions from the last class? No. Okay. Did any of you take a look at the video, the link that I sent you all from the first class? Okay, was the video okay? Whoever took a look at it, was the video okay? Oh, okay. Okay. All right. Well, let us get started today. We finished up section 1-1 on Tuesday. So now today we're going to do sections 1-2 and 1-3. Now, you will see very quickly why I'm going to have us do sections 1-2 and 1-3 because 1-2 is very, very short, and then we can complete 1-3 because typically, and I would just say this, I don't know about any other instructors, but whenever I could get a chance where we can advance a little ahead, and I'm not talking about 5 or 6 lessons, like maybe 1 or 2 ahead, that will give us a little breathing room a little later on for the lessons that will be a little longer. So what I want to do now, we're going to read through section 1-2. Oh, Cassandra, you have a question?
No, I do not. I'm sorry. I'm just trying to figure out how to do all this.
Oh, okay. Okay. All right. Well, I will mute you. Okay. All right. Now we're lesson 1-2, page 21. It says, where does the time go? Our learning objectives is to analyze personal time management for a week of activities, to solve problems involving percentages, to create and interpret pie charts, and to create and interpret bar graphs. Time is what we want most, but what we use worse. Okay, now we're going to slide down to the bottom here. And that quote was from William Penn. It says, where does the time go? I'm not asking in the philosophical way, as in, holy smokes, it's almost Halloween. Where does the time go? I'm thinking more literally. Where exactly does your time go? Have you ever kept track of what exactly you accomplish with the 24 hours you're given every day? If you have very limited funds, you have to be very careful about how you spend what you have. But we all have limited time, and not many people think about whether or not they're using that time wisely. Number one, what does the quote at the beginning of the lesson mean to you? Now, that is a subjective question, so there's no right or wrong answers. Does anyone have any idea what does this quote that I read earlier mean to you? Time is what we want most, but what we use worse. Does that mean anything to anyone? Okay, I see a few people typing in the chat. Let's see what's going to go on in the chat here. Okay. Well, as your fellow classmates are typing in the chat, I would just say this basically, time is what we want most because most of the times when you sit and talk to people, oh, okay. One person said it means to me we take time for granted. Yes, that's basically what that quote means. That's one of the meanings of that quote. That's very good. Let's see if we have anyone else as well. Okay, and what is meant, and basically I was going to touch on that with what I was going to explain. The way how we take time for granted is that we waste a lot of times doing a lot of things that will not afford us the things or the experiences that we want. And then as time starts to go away from us, we start wishing that we had all that time back. Now, another student said there is never enough time in the day, but it's really how you manage your time. Use your time wisely. Very, very good. And another student said where there is extra time, when there is extra time, we don't utilize it. And what I'm surmising, what the student is saying about extra time, talking about basically when we may have freed ourselves up. Like, for instance, you may have decided to cut back on your hours at work, but instead of utilizing that time for something that would be beneficial, a lot of people waste a lot of that time doing things they may not even really want to do. So that's good. So now we're going to move on to page 22. It says here, write down the 3 activities that you think you spend the most time on during an average week. Don't think about it too much. Just come up with 3 off the top of your head. Okay? Because someone volunteered 3 activities that they spend the most time on. All right. Someone typing in the chat. Okay. Cassandra? Yeah, Cassandra, you can speak. I saw you raise your hand. Oh, okay. All right. I have a student that said work, social media, and also watching TV. Those are their 3 top things they do throughout the week. Now, some of these may seem familiar to a lot of you because as human beings and also living in the United States, a lot of us have some of the same habits. Not all of us, but some of us do. And I will tell you what my 3 largest activities are, and I would rather use the activities before the pandemic. Mine were work, driving, and also sleeping. Those were the three biggest activities that I did throughout the week. Now, you all don't know this, but I live just outside of Detroit, Michigan. So it takes me about a good hour and a half to drive from my home to Jackson College. So that was a large activity for me today, for me in a day by driving back and forth. And then work, of course, you spend a lot of your time at work and then sleep. Getting 6 to 8 hours of sleep is a large activity as well. Okay, I also have one more. Have work, housework, and kids. Now, what I notice here with all 3 of our examples here, all of us had work first. so, so work does take up a lot of your time. Now, at the bottom here, it says, here's a sample time chart put together by a student who was interested in identifying the amount of time she spent for 1 week. Each hour is marked with C, time in class, H, time spent on homework, S, sleep, W, work, or O, other time commitments. In the portfolio portion of this lesson, you'll be asked to fill out a similar time chart of your own. For now, we'll analyze the chart. Now, basically, we're not going to spend that much time on the chart here. If you notice, there's a lot of O's, S's, and all those other letters. So what you were supposed to do is count up each one of those to determine the box you're supposed to fill out on the next page, which is number 3. It says count the number of spaces containing each letter in the time chart. CHSWO. Use the results to fill in the following chart, writing the total number of hours devoted to each activity during 1 week. Now, I already have this totaled up because, for lack of time, we don't have time to count up all of those letters. So class would be 15 hours. Homework would be 32 hours. Sleep is 54 hours. Work is 15 hours. And other is 52 hours. Now, this is for 1 week. So make sure you copy this down. Okay, now, it says here, they want us to also write down the total number of hours that we basically spend in a week with these activities here. When you add all these numbers up, it gives you 168 hours. Now, number 4, without adding the hours in the table, how can you decide what the total number of hours should be? So basically, if you take 7 days and multiply by 24 hours, because we only had 7 days in a week and we only had 24 hours in a day. So if you take the 7 days and multiply by 24 hours, that would give you 168 hours, which is what this totals to. Okay, now, we go down here to number 5. It says most college advisors will tell you that a good rule of thumb is to allow 2 hours of study time outside of class for each hour spent in class. Is the student who filled out the table on page 22 following that advice? So we could go back up here. Now remember, their class time is 15 hours. So they said allow 2 hours of study time. So we multiply that by 2. So we need a total of 30 hours or more to be within that. Now, there's no place on this chart that says studying. So we're going to use homework as the gauge for their studying. Homework here is 32 hours. So yes, they are doing quite well. So they exceed this recommendation by 2 hours because they actually got 32 hours in. So they're doing quite well. Okay, now we come here to problem number 6. It says one really good way to analyze the time spent on various activities is to compute percentages. Use the time spent on each activity and the total time in a week to calculate the percentage of time spent on each activity. Round to the nearest percent. Now, before we go in here and determine the percentage, we need to talk about what does round to the nearest percent mean. Because when you get your final answer, you're supposed to round it to the nearest percent. So, in order for you to round to the nearest percent, what you first need to do is round to 2 decimal places. Because we know from Tuesday, when we went on over decimal to percent and percent to decimal, we know we have to move that decimal 2 places. So if you round to 2 decimal places, when you change that decimal to a percent, you're going to move that decimal 2 places to the right. So to make it easier for you, just round to 2 decimal places and then you could easily write the percent. So we're going to go through how you would determine the percent. So I'm going to write how you would determine the percent on the side here, and then write down the actual percentages here. So first thing we know, there's 168 hours in a week. So that's going to be our denominator. Our numerator is going to be how many hours we have for each activity. For class is 15. So we have 15 over 168. For homework is 32. So that'll be 32 over 168. For sleep is 54. It's 54 over 168. Work is 15 over 168. And then finally, other would be 52 over 168, based upon the chart that we had earlier. Now we're going to take these values and we're going to use Desmos here to help us out. We're going to take these values and put them in the calculator. So we have 15 divided by 168. And when we round this to do 2 decimal places, that would give us 0.09. And we have to use these squiggly lines because that's an approximation. So 15 over 168 is 0.09. So if we make that into a percent, we'll move that decimal 2 places to the right. So it'll be 9%. Now, we can skip down to work because remember, work and class has the same amount of hours. So we know that answer will be the same. So work will also be 9%. Now we go back here to homework. We can have 32 divided by 168. Round that to 2 decimal places, and it'll be approximately 0.19. So we'll move that decimal place 2 places to the right, and that would give us 19%. Okay, next we would do sleep. 54 over 168. Round it to 2 decimal places, it's approximately 0.32. And we know we have to move that decimal 2 places to the right, so it'll be 32%. And last but not least, it'll be 52 over 168. I can back up and put the 52 here, round to 2 decimal places, and it'll be approximately 0.31. Move it 2 places to the right, it'll be 31%. Now, when you add all these percentages up, it should equal 100% or very, very close to 100%. And the reason why sometimes it won't equal exactly 100% is because, remember, we're doing approximations. So it may go over a little over or a little under. Okay, now we come here to problem number 7. It says studies have shown that college students get about 6.5 hours of sleep per night on average, but that academic achievement improves when students average 8 hours of sleep. What percentage of the hours in a week would be devoted to sleep if you got 6.5 hours of sleep per night? What if you got 8 hours? How do you feel our friend from question 1 is doing when it comes to sleep? So what we're going to do first, we're going to deal with that 6.5 hours first. So we have 6.5, and we know it's 7 days in a week. So we'll multiply that by 7. Now we know 6.5 is really 6.5 times 7. Now we can use Desmos to multiply that out, 6.5 times 7. And that would give us 45.5 hours. Now, they want us to write this out as a percent for how many hours in a week would be devoted to sleep. So remember, it's 168 hours in a week. So you would take this value here, it's 45.5, and divide it by 168. Now, it did not say for us to round it to the nearest percent, but we're going to do that. So we round this to 2 decimal places. So we have 0.27, and then move it 2 places to the right, so that'll be 27%. So that's 27% with the 6.5 hours. Now I'm going to separate this from the 8 hours. Now 8 hours, we'll just take 8 times 7, which is 56. And then we would take our 56 divided by 168. Look like I skipped, so I could click here. All right, so if you notice here, if we round the 2 decimal places, it's approximately 0.33, which is 33%. So basically here, they're saying that you need about 33% worth of sleep in order to be at your best level. Okay, now, finally, they want us to tell how our friend is doing. Now, if we look here, as far as sleep is concerned, our friend is doing 54 hours. So it'll be 54 over 168, which we actually already did here when we got this percent here. So we don't need to put in Desmos because we already have the percent. So it's 32%. Now, if you look here, they say, how do you feel our friend is doing when it comes to sleep? So basically we could say not bad, only missing 2 hours per week of sleep, or about 1%, which actually isn't bad. It could be better, but it's still not bad. All right, now, before we move on, did you all have any questions over anything we've covered so far? Any questions? All right, now, before we do number 8, someone else put in the chat what they thought the initial quote was, so I want to acknowledge them as well. They put down, there is never enough time for the things we need to do, because I guess they wanted to say we procrastinate, but they put I procrastinate, but that's fine. And that is so true. Okay, now, we only have one more problem to complete from section 1, 2, and we are done. That problem is actually on page 25. Now, 24, let me go back to 24. There's a little explanation here, but not an actual problem. It says a circle can be divided into 360 equal units of measure, which we call degrees. In other words, an entire circle is made up of 360 degrees. The degree symbol, well, that circle, that raised circle symbol represents degrees. A pie chart is a diagram used to compare the relative sizes of different parts of a whole. In solved example 1, we'll have a look at how a pie chart might be constructed. But we'll take a look at that a little later. Well, I guess we could take a look at that now. It says identifying the elements of a pie chart. The pie chart to the right, adapted from USA Today survey, describes people hand washing tendencies when using a public restroom. How many degrees are covered by each of the portions in the pie chart? So if you look here, it says 70% say they always wash their hands after using a public restroom. 29% says sometimes, and 1% says never. Now that is bad, but should be 100%, but that's something for another time. Okay, the solution. It says the key is recognizing the percentages described by each portion. The chart indicates that these percentages of folks surveyed gave each response. And we see that in the pie chart, and now it's written out. We know that the total number of degrees in the circle is 360. To find the number of degrees corresponding to each response, we'll multiply the percentage by 360 degrees. But remember, we need to multiply the percentage in decimal form, not percent form. Here are the degree results. So 70% would be 0.70 times 360, so that'll be 252 degrees. Sometimes it's 29%, we would change that to 0.29 and multiply by 360 and get 104.4 degrees. And then never is 0.01 times 360, which is 3.6 degrees. These are the number of degrees covered by each portion of the chart. Does anyone have any question about finding the degrees? Any questions on finding degrees? Now, the one thing that was not stated on that page is this here. Sometimes when you multiply out your degrees, if you add them all together, they would not necessarily equal to 360. They're supposed to equal as close to 360 as possible, only because sometimes we have to round. Okay, number 8. It says use the procedure from solved example 1 to find the number of degrees in a pie chart that will correspond to each activity in the chart from question 6. Put the results into the next chart. Round to the nearest whole degree. So when they ask us to round to the nearest whole degree, they're basically asking us to round to the nearest whole number. So now we want the degrees of the class, homework, sleep, work, and other. Now, let's write out first the percentages we had. We had for the class, well, I'm going to write it in front of it. We had 9%. For the homework, we had 19%. Sleep was 32%. Work was 9%. And other was 31%. Okay, these were the percentages for each of these. So now we have to find the degrees. To find the degrees, we would change these percents to decimals. So this would be 0.09, 0.19, 0.32, 0.09, and 0.31. Now we will multiply all of these by 360 degrees. Now, some of these we're going to have to change to squiggly lines because they want us to round to the nearest whole number. So we will go right here to Desmos. I just want to clear a little bit of this up. All right, now we could take 0.09 times 360, and that's 32.4. So we would do an approximation. It'll be 32 degrees. Next, we will have 0.19 times 360. Round that to 68.4, or just 68 degrees since we rounded to the whole degree. Okay, next we have 0.32 times 360. Round that will give us approximately 115 degrees. And we already have 0.09 times 360, which would be that 32 degrees, but it's also an estimate. Now, last but not least, we could do 0.31, and that would give us approximately 112 degrees. And basically, that is it, and this does not equal to 360 if you add them up. So, are there any questions on section 1, 2? Because this is it for section 1, 2. All right. Okay, now we're going to go over here to section 1.3. And right before we start section 1.3, I want to talk to you all about the course packs. Now, I was told that your course packs will be mailed out as soon as possible. I don't know if some of you all received the, I guess it would be called the workbook for the course. Did you all get that? Okay. Well, if you don't have it, and I see someone said they do have it, and some say they do not. If you don't have it, again, it will be coming to you very soon. Very soon. I forgot. Well, I will come back to this, but I wanted to tell you, let me see if I can find it. I know it's one of these problems. I can't remember which one it is. So just give me a second, because since you all do not have your workbook, I have been telling you all which one of these is the lesson check. So let me go and find that so I can let you all know which one of those are the lesson check assignment. Let's see. Okay, now, so for section, oh, that was 1.1. Hold on, I need to go to 1.2. Okay, the question for the lesson check will be, it's on page 23, question 6. So even if you cannot recognize what page 23 is with 1.2, we only did number 6 one time. So it's still just find number 6 in the video, and that's the one that you will give the answer for. Now, one other thing, and I believe some people have some points knocked off, but here it tells you to round to the nearest percent. So you'll put your answer here, we know it's the nearest whole percent. You'll click the down arrow and hit percent. You would just write the number without the percent symbol, and then you would get the percent symbol from this drop down arrow here. Okay, now, are there any questions before we go to section 1.3?
I have a question for you. We were working on the worksheet yesterday that you want uploaded by Sunday, and I'm having them uploaded to me as well, but many of them don't have the worksheets yet, so I told them it was okay with me to upload it, just the answers on a piece of paper. But what do you want to do about that?
They could upload it to me, answers on a sheet of paper, answers and showing their work too. Yeah. So, whatever work you had to do to get it. Now, some things, let me just explain this to you. Let me just show this first, and then I'll explain about what I mean by show your work, because it's a little different meaning. But listen, when we get to 1.3, you may want to write this down. It's page 46, question number 1. Okay, page 46, question number 1. Now, Miss Nolan, if you got the 130 course pack, I think that's the one that has the worksheets in it, because it's kind of thin. Is it kind of thin?
Yes. Is it for, because I received the 130 course pack, so that goes along with 140 as well?
Yes, because that has worksheets in it. So if you notice, it said
Yeah.
worksheets, exam reviews, and something else. Yeah. So you would
Quizzes, I
use
think.
that in order to do your work. Now, if you did not receive that packet, oh, by the way, with 130, there is a table of contents in that smaller pack of notes. There is there's a table of contents, but I know that the math 130 starts on page 60 and ends on page 99.
Yep.
So I'm
Okay.
just letting you know that. So it starts on page 60, ends on page 99 for 130. And I think the 040 is before that. Goes from like page 1 to page 59. And then we have some exam reviews and all of that.
So I received everything I
No,
needed to then?
what I'm using right now,
Oh, okay.
they consider this they don't consider this the course pack. I forgot what they consider it, but it's supposed to be mailed out
I
to
think
you.
I think the bookstore calls it a course book, and it makes it confusing because then they have the course
Right.
pack
And
too.
that course pack is just basically the worksheets for our class, worksheets and the reviews.
Yeah.
So what I'm working
It's a little
out
confusing.
right now, I mean, this might be considered the workbook or something like that, but this is what you actually use for your notes. And I know you all don't have it right now. Okay, look like someone is typing something in the chat, and then we'll get back. Did you all have any other questions? Okay, as people are typing, let me just say this here. If you have not signed up for Alex yet, please sign up for Alex. I think we almost have everyone signed up for Alex except for maybe about 1 or 2 people. So please sign up for Alex. All right. So now we're at section 1.3 on page 39. It says, take a guess. The learning objective is to identify the steps in a systematic problem-solving procedure. Make educated guesses and compare numbers using inequality symbols. Okay, now I'm going to skip over a few things here just to get to the meat of it. But this quote by Michael Jordan, don't be afraid to fail. Be afraid not to try. Okay. It says, consider the scenario. You're a contestant on a game show and you're given a trivia question worth $50,000. Pressure. The question is, which state was first to secede from the Union in 1860? Do you know the answer? If so, terrific. Drinks are on you. But if you don't know the answer, you have to guess. Would your list of guesses include the Pacific Ocean, Justin Bieber, Twinkies, and a goat? Of course not. Those would be completely ridiculous, and you're not a goof. The point is that guessing doesn't usually mean just throwing out some random answer and praying for a miracle. Instead, we use information we know to be true and some reasoning ability to make an educated guess. In this section, we'll try to gain some confidence with educated guessing, which sometimes goes by a different name in math, estimation. From an instructor's point of view, it seems like in math class, a lot of students are afraid to make educated guesses, but sometimes that's a completely reasonable step in problem solving. Nobody likes to be wrong, but if you're not willing to at least answer a question, you have no chance at ever being right. Not being afraid of failure is one of the characteristics shared by almost everyone who is very successful in their chosen field. Okay. We're going to scroll down here to number 1. It says, write a brief description of 2 or 3 problems that you've had to solve outside of school. Okay. Well, I'll name a couple of mine, and then I'll take a few of yours. Okay, one problem I had to solve was choosing my children's school. The second, and I would just say this, I'm not asking anybody about this, but choosing to take the vaccine or not. So those were two decisions, two big decisions I had to make outside of school. Does anyone have a decision? Oh, I see someone said choosing to move. I'll just add that here. Choosing to move. Anyone else? So maybe we can get like one or two more. Let's see, number 4. Let's see, choosing. Oh, quitting my job for school. Wow, that was a major decision. Okay, number 5. And that'll be the last one. Oh, finding work that works with school availability. Yeah, that's very important. All right. Now, those were some examples. Okay, we move on over here. It says problem 2. What are some methods that you use to solve problems in your life? Do you think that they apply to solving problems in college classes? Okay, well, I think one thing that I do is try to make sense of what's going on. Because if you don't understand what's going on, there's no way you'll be able to solve the problem. Okay. The second thing that I would do is try to find a way to solve it. I.e., or for example, get a plan. Get a plan together. Okay, number 3. Well, you got to act on a plan. And then finally, what I would do after I act on a plan, I would see if it works. And then if it doesn't work, I have to start over. So what we have here, these are the steps that I usually take when I'm trying to solve a problem, but they are very similar to Palia's 4-step procedures for solving problems. Now, of course, you don't have to copy this down because this is actually in your course pack, but it's good for you to familiarize yourself with this. So let's go down here to the bottom. It says estimation is a valuable skill when it comes to reading information from charts and graphs. In fact, we've used that skill several times already. For example, when reading a bar graph, if the length of a bar falls between two lines, we have to estimate its height. We can practice this useful skill by looking at a number of lines. This number line is a timeline of important advances in medical science. Use it to answer questions 3 through 10. All right. I'm gonna have to have this somewhere up here. Okay. Now it says, estimate the year that the microscope was invented and describe how you got your answer. So we go here, microscope invented. As you see that we're going by intervals because this is 1500. This must be 1550. This is 1600, 1650, 1700, and so on. So if we look here, this is very, very close to 1600. And we know this is broken up into 50s here, into 50 parts. Okay, so if I were to estimate it, I would say around 1590. I say around 1590, real close to 1600, but not close enough. Then it said, describe how you got your answer. I would say real close. It says real close to 1600. And since 50 is the highest amount, added to the date, after, well, it's added to the date on either side of the 100th year. So when I'm saying that we have 1500, we have 1600. That's 100 years in between them. So what I'm saying is on either side of this, as far as the middle term is concerned, we know this is broken down into 50s. So 1500 to 1550 is 50. 1550 to 1600 is still 50. And since it's only 50 there, we know that, that point is real close, but not quite there yet. So I could just see it being 10 off. Okay, number 4. It says, estimate the year that germs were identified as the cause of disease and describe how you got your answer. Okay, it says germs identified as cause of a disease. If you notice here, it's a little bit past the center. So I would just say that's about 1860. And I would say that the date is a little past the center of 1800 and 1900. Number 5, which happened first? The first test tube baby or the first heart transplant? So we go here, the first heart transplant, then now the first test tube baby. Okay, if you look here, it looks as though the heart transplant is right. It's like right in the center between 1950 to 2000. So I would say it's about 1975. So we could say, and I'm going to abbreviate this, as heart transplant is HT. And I would say 1975. And then the second is the test tube baby. So I'll put TTB. So the test tube baby, it looks as though, it looks as though it's a little bit past half between 1950 and 2000. So I would say that probably would have been like 1980, about 1980. And then it says, okay, we estimated the year for each. It says, which happened first? Organs grown from stem cells or the identification of HIV? So we look here. Organs grown from stem cells was a little after 2000. And identification of HIV, it looks as though it's here like in the 80s. Okay, so we look here, HIV was identified first. Now they want us to estimate the year for each. So with HIV, looking here, says a little bit off the center, but very, very close. Well, no, it's actually, yeah, this looks like this might be maybe about 1990, well, I would say 1985. Okay, next is the stem cell, the organ growth from stem cells. The OGST, organ growth from stem cells. All right. Well, I should say OGSE. Okay. All right. So organs grown from stem cells. You look there, that's a little bit past the 2000s. Maybe about, let me see, probably about 2010. All right. We're going to take a quick 5-minute break and then we'll come back and finish up section 1-3. Okay, class, we are back. Okay, now we need to go to the bottom of page 41. And we have this tan box here about comparing numbers. And it starts off with, there are several places in this course where comparing the sizes of number plays a key role. So it's worth a bit of our time to review some of the symbols and terminology that go along with these comparisons. In some cases, our example comparisons will involve just numbers, and others will be using letters to represent variable quantities. So if you look here, we know what equal means, that these two values are the same, even though they look different. And then we have x is approximately equal to 10. We use those squiggly lines, which lets us know that that's approximation. The not equal sign. And then we have less than. Now, a lot of people are taught inequalities by going with the mouth and everything like that. However, I always teach inequalities that the inequality always points to the lowest number. It always points to the lowest number. So this is why this is 10 is less than 12, because it's pointing to the lowest number. Now, we have another symbol here. Now, some people have not seen this symbol before, but this is a less than or equal to, which basically means that as long as it's less than the value or equal to the value, then it satisfies that inequality. Now here is the greater than symbol, and then this is greater than or equal to, which means that it can equal that value or be larger. All right. So now we move on to page 42. Number 7. It says use your answer from question 5 to write an inequality involving less than that compares the dates for the advances mentioned in that question. Now, we look here at number 5. It says which happened first, the first test tube baby or the first heart transplant. Now, here's a little issue with this problem here. If we're going by dates, we could do this, and this is how I did in my other class, so I'm going to stick with this method. I always have the lower date as the lower value, because there is a way you could form the question where the higher date would be the lower value. So, but the lower date would be the lower value, which would mean here that it came first. So if we look here, the heart transplant came before the test tube baby. So we could just say heart transplant is less than the test tube baby. And we're talking strictly dates here, which means that the heart transplant came before the test tube baby. Now number 8, it says use your answer from question 6 to write an inequality involving greater than that compares the dates for advances mentioned in that question. Now if we go back here to number 6, this is HIV and the organs grown from stem cells. Now if you notice, organs grown from stem cells came later, which means that it's a greater date, which is 2010. So the organs grown from skin cells has a greater date than, I believe, what was it, HIV? Yes, than HIV, which lets you know that HIV came first as far as date-wise. Now, number 9, the 2 most recent events on the timeline are organs grown from stem cells and skin cells grown into stem cells. How do the dates compare? All right. When we look back here, these 2 dates here. Now, depending on your perspective, you can say that it looks like they hit the same date. So you could do an equal sign. Or you could say that it looks as though the organs grown from stem cells came before skin cells used to grow stem cells. Now, to me, it looks like they're the same date because it looked like they're crossing each other. So I would just say that the organ grown from the organs grown from stem cells is equal to the skin cells grown into stem cells. All right. Now we move on here. To problem number 10. It says your first instinct might be that growing stem cells from skin cells came later because the words are set further right, but their position on the graph indicates that they might also have occurred in the same year. When comparing 2 quantities that may be equal, we can use the symbol less than or equal to, which is read less than or equal to, or greater than or equal to, which reads greater than or equal to. Use one of the symbols introduced in the previous paragraph to describe the relationship between the dates of organs being grown from stem cells and stem cells being grown from skin cells. Do so using verbal descriptions of those quantities first, then assign a letter to represent each quantity and write a second inequality with your variable. Now that was a mouthful. So this is what we would do. First, let's write out what we think we see here based upon what was told to us. I'm going to abbreviate. So the organs grown from stem cells has an earlier or same date as the skin cells grown into stem cells. I just abbreviate that as well. Now that's one way to look at it. Or you could say the skin cells that grow stem cells has the same or later date than the organs grown from stem cells. Now, if we want to write that out, we do OGSC is earlier, so it's less than or equal to SCGSC. And remember, those are my abbreviations because that is a lot to write. And then we have here, oh, you know what? They actually told us to assign a letter. So let me do that real quick. Since I have the abbreviations here, we can make this X and make this Y. So we know that these are X and Y. So let me write it here. This would be X is less than or equal to Y. That will represent this here. And we could still use the same thing here. So this would be Y is greater than or equal to X. Okay, now, before we move on, are there any questions? Okay. Now we go here to the next page. Oh, actually, there was a little directions here at the bottom of the previous page. It says, now we'll practice estimation using a bar graph. The next graph shows the average monthly cost of homeowners insurance in 5 states that are common destinations for people hoping to move to a warmer climate. Use it for questions 11 through 15. Okay. It says, estimate the monthly cost of homeowners insurance in California. What do you all think that the estimated cost of homeowners insurance is in California based upon the graph? Anyone? Okay. Can you all hear me?
I can.
Oh, okay. Well, I guess everybody's a little shy today, so I know that. Oh, okay. Someone put down 80. Oh, okay. It's $80, but I get what you're saying. Someone put down 80. Anyone else? Okay, $80. All right. Now, $80 is a very, very good guess. However, there's just one little thing here. It's slightly above the $80. So like someone put $82, that's about right, because if you look here, from 80 to 100, each one of these lines go up by 20. And this is slightly above this line, so I can see it being $2 extra. So about $82. All right, now it says, do you think your estimate may be too high or too low? Why? Okay, look in here. I guess I would have to say, I would go on the it is too low side. It is too low because if I am accurate, I would be barely so. Now, the reason why I would say that it's too low, whenever you're making out a budget, a lot of times you want to overestimate first until you see what things actually are. Because if you overestimate, the worst that'll come out of that situation is you will come home with more money. But if you underestimate, then that means that, you know, if it's your utilities or other bills, that it could be shut off because you didn't pay enough, or you could pay penalties and fines. So that's why I would go on the side of that it might be a little too low. Okay, 13. Using your answers to questions 11 and 12, write an inequality using either greater than or equal to or less than or equal to that describes the cost of homeowners insurance in California. Use letter C to represent the cost. So you would think that the cost must be, since I feel that this is on the low side, the cost must be greater than or equal to $82. Because remember, I feel that the cost in California, the $82 would be too low. So I'm thinking that it would either be greater than or equal to it. Does everyone follow that? All right. 14. Suppose that you were planning to move to Arizona and wanted to budget a monthly amount for homeowners insurance. Would you prefer an overestimate or an underestimate? Explain. Just like I said before, I would prefer an overestimate just to make sure I have enough money to pay the bill. That would be my reasoning. No, I'd rather overestimate so I make sure I have enough money to pay the bill. What estimate would you use for the monthly cost of homeowners insurance in Arizona? Okay, when we look at Arizona, what do you all think there? Hey, I see 55. Anyone else? Okay, well, let's take a look at it. Now, if you look here, you go from 40 to 60, and you see it's very close to 60. Now, I'm glad that you went past 50 because 50 would be the halfway point between 40 and 60. So you went past 50, which was a good thing. You went up to 55, which is also a good thing. But I think it might just be just a little higher because of how close it is to the 60. So I see someone put in 58. So I would think about the $57, $58 range. So $57, $58, I think would be more so where we would be at with that. But still, excellent guess. All right, now it says the following box describes some words in English that are used to describe the inequality symbols we've been working with. Okay, now if you notice here, the less than symbol is less than, fewer than. Greater than symbol is greater than or more than. Now we add a less than or equal to, but it also means at most, no more than, a maximum of, or less or lower. Greater than or equal to would be at least, no less than, a minimum of, or more or higher. One of the more important skills in college math is being able to translate between verbal and symbolic language. We're going to get some practice at that by working with the inequality symbols we just reviewed. Now we're going to work with them on the next page. Now in questions 16 to 19, write the statement as an inequality, then give an example of an actual value that would match each description and satisfy the inequality. Then give an example of a value that satisfies the inequality but doesn't make sense in the context of the statement. We can fit at most 12 people on the slow ride pedal bus. Now, if they're telling us at most, that means we could fit that amount or lower. So we could use, for the slow ride pedal bus, we could use B. So we could have B must be less than or equal to 12. Because we could have 12 people or less. 17. It's estimated that there are at least 50 ways to leave your lover. So we'll put L for lover, and it says at least 50 ways to do that. So you could put the lover as far as leaving your lover. I probably should put LL for leaving lover. And it's greater than or equal to 50 because it's at least. 18. I get a text alert from my bank if the balance in my checking account drops below $100. So basically we would have the alert to be A. The alert happens when the account goes less than $100. It's not equal to 100, you got to drop below. Now 19, any amendment to the U.S. Constitution will only be enacted if more than 37 states vote to accept it. So we could put down S for states. So the states must be greater than 37. There's no or equal to because it says more than. All right. Now we go here to the back. Now this question here, the first question is actually your check assignment for section 1.3. So it says an isotherm is a curve on a map that connects locations where the temperature is the same. By looking at a large map with isotherms, you can get a rough idea of what the temperature is like in many different locations. Using the map, estimate the temperature in each city. Now, L represents Las Vegas, and if you notice, the L is directly on this line. So that would be exactly 40 degrees. To Phoenix, Arizona, which is a P. You notice here that this is more than half and is close to 50. So that'll be maybe about 47 or 48. Dallas, Texas, D. It looks like it's right in the center of 20 and 30. So I will go with 25. Springfield, Illinois with the S. You notice here this is closer to 10 degrees than it is to 0 degrees. So I probably would go like more so 8 degrees. Atlanta, Georgia, A, in between 30 and 40, but closer to 30. I would think like that might be 32, 33. Next, we have Miami, Florida, M. M right here is a little bit past 50. So I would just think about maybe 52. New York, New York, which is N. Now we look here, N is right here. It's in between 0 and -10, but closer to 0. So I probably will put it at a -2 degrees. Now, are there any questions? Now we're going to do a little bit more estimation. Let's look here at number 10 on the next page. It says, about how much would you spend in a year if you bought two $2.80 cups of coffee each weekday, Monday through Friday? Does this amount surprise you? Does it sound worth the expense? Now, we could do this one or two ways. We could round up to $3 and go from there. Or, because it does not say anything about an estimation. So listen, what was assumed here is that if we were in class face to face, you and your group mates would sit down and try and estimate to see where you all fall at as far as the estimation versus the actual amount. But since we're online, what we could do is this. We could take our $2.80 and let's say you get it twice in a day. So that'd be $5.60. And then it will be each week. Now remember, it's 52 weeks in a year. So we'll do some multiplication here. Oh. So it'd be $291.20. That's how much you would spend in a year on coffee. Now, whether it surprises you or not, I guess that depends on if you're a coffee drinker. And it says, do it sound worth the expense? I would imagine it would for a coffee drinker, but for someone that doesn't drink coffee, it would be too much. Okay, number 11. Okay, let's go to number 12. Number 11, we're going to do something like that a little in a later chapter. But number 12, and I believe this is our last problem for today. It says, how much money are you completely wasting every time you skip a college class? What information would you need to calculate that exactly? Does anyone know what information you would need to be able to calculate how much you're losing every time you skip class? Or a person skips class? Okay, that's good. Tuition amount. Cost per class. Credit per hour. It'd be cost per hour, really. Okay. Or cost per credit hour. Okay. But I knew what you meant. Okay, so now, this is true. And then you also need to know how many credits for the course. And then also how long is the course. So if you have these, you should be able to calculate it. So let's just say at Jackson, let's just say for a class, it end up being $4,000 for the one class. Now, you got $4,000, and then let's just say you're doing 4 credit hours. Divided by 4, so that's $1,000 a credit hour, which Jackson College doesn't charge. But let's just say you're going someplace that will charge you $1,000 per credit hour. Okay, so we got this $1,000 per credit hour. We will have to divide up, because I said how long is the course. We have to divide up the course by how many class meetings there are. So technically, we didn't need the cost per credit hour. Well, technically we did, because then that'll let you know how much the whole class costs if you had that. But we would take the $4,000 and divide it by, we typically do a 15-week semester. So we would divide this by, and say you met twice a week. So, and 2 hours a day. So, let me see. It would be 30. And let's say it's a 4 credit. Let's say it's a 4 credit class. So it'd be 30 times 4. Now 30 times 4 would be how many hours that you spend in the class. Because you're going to do 30 class sessions, 4 hours a week. So if you take that $4,000, or you know what, actually, you know what, this is if we wanted it in hours, but we're just trying to do it in a class session. So let's just do 4,000 divided by 30, because we're going to, it'll be, let me see, 30 class sessions, because you would do 2 class sessions a week. So if you do 4,000 divided by 30, then what you would be losing out on every class session is $133 and about 33 cents. That's how much you would lose for every class session that you do not come to. That's a nice amount of money. All right. And then it says, well, basically, you know, you'll need to ask yourself if it's worth it or not. So that's basically it for today's lessons of 1, 2, and 1, 3. Now, just to do a little housekeeping here, remember your lesson check and your worksheets for 1, 1, and 1, 2 are due this coming Sunday. 1, 3, the lesson check and the worksheet is not due, I believe, until the following Sunday. So you really don't have to concentrate on 1, 3. Just make sure you get 1, 1, and 1, 2 done first. And then once you're done with those, then you could do the 1, 3. Now, did you all have any questions, anything about Alex, anything about JetNet, anything about uploading, anything about scanning, anything? Did you all have a question?
Well, I have a student that's contacted me about the Alex objective, I guess. She said that she continues to do the objectives and it keeps telling her that she has 24 of them. Is anybody else experiencing that? You all doing okay?
Is everyone still here?
Yeah. It just seems odd with Alex. So I wondered if anybody else was having any trouble.
So the student that did it, they said they only have 24 to go, or they have 24 that was completed.
She has, this is what she said. Okay. Unit 1, Alex, it says there's 24 topics. I've been working on it for about an hour and went through a lot of topics, but it still says I need to complete 24 topics. And then she said, I asked her what her score, how she was doing on them. She said she got about 3 incorrect. But
You got about 3 incorrect.
yeah, but then she still had to redo it. Did the progress.
But she didn't reveal how many that she actually completed.
Yeah.
She just said she got 3 incorrect. So it might still be telling her, it could be one or two things. It could be telling her that her overall as to what she needs to complete, or she may not have fully completed one of them.
Okay.
And she got 3 wrong and thinking that something is going wrong because she may have done maybe about 5, 6 problems and then got 3 other ones wrong and thought that, maybe it should be, counted. But
Okay.
that could be one possibility, or it could be a glitch. But the only problem that I'm having is I don't know. I guess if the student is on the call, just email me or reach out to me. Or Ms. Stewart, you could send me the student, then I could go and check and see if they got any credit.
Yeah, she's not on the call, but she said that she would be sending you an email.
Oh, okay.
I think she'll be watching the Zoom recording later too. So this will help.
Okay, if you are watching a video and this was what you sent to Ms. Stewart, please email me so I can take a look at what you're talking about.
Okay.
Because I noticed in the chat, no one else is having that issue.
Yeah.
But, sometimes that happens. Sometimes it's just, your account for some reason, because I've had plenty of that happen before.
Yeah, some parts of Alex is just kind of strange sometimes. Hard to figure out. Okay. That helps.
So, I'm sorry. Tina is typing. So does anyone have any questions, comments, or you all are just ready to get ready for the holiday on Monday?
I'm ready. Well, I'm ready for the whole weekend.
Oh yes. I understand. I truly understand. All right, well, if there are no questions, what I would suggest that you do is start working on your ALEKS, complete the worksheets, complete the lesson check, and anything. Okay. I had one student here saying that they're having trouble staying connected on Big Blue Button, but the Zoom is working fine. What browser are you using? Oh, it looked like the student is off again. Okay, I guess I'll catch up with her to see what browser she's using.
Okay.
Okay. So, like I said, you all can work on those lesson checks, the worksheets, get them in. Please do not wait until Sunday night and then decide to contact me that you all were not able to get everything put in, because that would be too late. You say you're using Thursday's link. Yeah, that's what I use too.
Yeah.
Yeah. What browser are you using? Okay, class, if there's no other questions, you're free to go. If you If you have questions, you can stick around. Oh, look.
Thank you.
I'm not sure what browser it is.
You say you're not sure what browser it is?
No, I just get in on my JetNet and I load in your class and then I go down to Tuesday and Thursday's link of this week and it keeps cutting in and out. But when I watched the video for Monday, everything was fine.
Okay, let me ask you this here. What type of computer are you using?
An HP?
Okay. Are you clicking on what looks like an E, or are you clicking on to get on the internet? Are you clicking on the E, or are you clicking on Google Chrome?
Google Chrome.
Okay. So with you clicking on Google Chrome, it could be that when you're accessing the big blue button, it could be that you can have a pop-up blocker on that you may need
Okay.
to turn off, or it could be that big blue button could be a little glitchy. But I would check that. I would check that out.
But if I try on Internet Explorer, it might come in better.
Oh, it might.
Okay, I
It
might try
might.
that too because I start to hear you and then it cuts out and then I'll get back on, I'll refresh it and I get back on and I can hear you for a minute and then it goes right back out. So I'm trying not to miss anything.
Okay. Well, what you
Okay,
can do,
I will try that.
why don't you sign out now and then go and get on
Okay.
Internet Explorer and try and sign into the class? I'll stay on for that.
Okay.
But I think
Okay.
I'm going to stop this recording unless there's any other questions.
That's it for me. Thank you.
Okay, no problem.